As we have our service currently implemented here, the service will basically start up on the first request and will remain running basically either until some outside caller calls stop service on the service, or the device resources run low enough that the operating system finally has to kill the service. That's probably not how we want to implement this service, right? The idea we're trying to do here is that, well, when there's requests to go ahead and get the location and store it, we keep that GPS running in the background so that we actually can kind of service the request very quickly with a fairly accurate location. But at the same time, GPS work is fairly power intensive. Right? As a result, if nobody's making calls into our service, then it probably doesn't make sense to keep consuming all that power with the GPS. So we probably want to start putting in some kind of conditional stop on this. Right? So in order to actually call stop on the service from inside of here, we need a reference to the service. Right? So we probably want to call that stop somewhere in here where we're actually doing the work for each request. Right? Because if we were to call stop self somewhere out here, right, basically we would actually stop the service suddenly before we ever had a chance to even do the work. Right? So we're going to really want to do our stop calls inside this handler. To do that, that means we're going to need to have some way of actually having a reference to the service accessible inside of the code here that runs on that background thread. So probably the thing for us to do is, rather than just creating a runnable instance right here, what we call execute, is let's go ahead and just implement a class that implements the runnable interface, and we can pass a reference to the service into that class. So what I'm going to do here is go down here and just create a private class inside of my worker service class. And we'll just call this class service runnable. Alright, so I'll go here, start with, and just go ahead and grab all this code, because that's what I'm going to want to do inside there, is this work. And so I've now got my runnable implementation. And since I want to be able to pass a reference to the service in here, I'm going to just create a constructor for it that takes a reference to the service. My service is called worker service, so that's what we'll take a reference to. We'll just go ahead and store that in a class level field. Right, now what we have to do is assign that in here. So what that would allow us to do at that point is that up here, again, rather than just doing all this stuff on the fly, let me get rid of that code here. All right, and what we can do now is simply create an instance of our class. Right, pass a reference to this. Right, and then with that, I'll go ahead and again, I'll actually pass in that reference to my executor service. Right, so let's grab my executor service. Execute, and I'll pass in my runnable. Right, so now what will happen is that we create the instance of our class. Right, we pass it into the executor. And what will happen, of course, is that we call our run. Well, we've got a reference to the service. Right, so what we could then do here is say, well, the service, and I could say something like stop self. Right, now, if I were to do that, what that would say is that when I get a request, as soon as I finish the request, stop the service. Right, well, that might work okay if I was only getting one request, but remember our concern is that we've created the service to be able to handle multiple requests. So what we really want to say here is, I want to stop myself only if I'm the last request that's coming in. So what happens is that there's actually, in addition to stop self, there's another method we have here called stop self result. And that takes in a start ID. And if you notice up here, on our onStart command, we get a parameter here called start ID. Right? That's our request ID. The value is not meaningful except for the fact that that is an ID into the service management system that's keeping track of all the requests that are coming into our service. So what we want to do is we want to say stop ourself only if we're the last request that was received. So what we want to be able to do is pass in this start ID. Now, one thing to be careful of is that there's a stop self method that takes a start ID. That's actually been deprecated and replaced with stop self result. What stop self result does, it accepts that start ID and it returns a true or false. If it returns true, it says that, yes, you were the last request, so you're going to go ahead and be shut down. If it returns false, it means no, there are other requests to be processed, so you're not about to be shut down. So if you need to know that information, you can check the result for stop self result. Now, what we need, of course, is to make this call work, is to actually get that start ID. So what we really need to do is expand our constructor here, and allow it to accept the start ID. So I say int start ID. I'll declare a class level field to hold it again. Right, I'll just go ahead and store that in here. So that means up here, when we construct the instance, we're going to go ahead and pass in the start ID as well. So now we can say stop self result passing in that start ID. And so now with each request as it comes along, if we're the last request, we'll go ahead and shut down. If there were other requests that were coming in, we'll then continue to run. Right? So we're kind of saying go ahead and shut me down as long as they have nothing else to do. Right? And for a lot of services, that's actually a fine implementation. Right? Particularly if you're something that's very on request oriented. But the thing that's interesting to note though is that in many cases where that model works, where you want to stop self at the end of each request, actually the intent service that we talked about before is often a better choice because it does a lot of this kind of housekeeping stuff for you. But again, what might be really useful in our case is that we want to keep the service running for some period of time as long as it remains in use. So maybe we want to shut down, as I mentioned before, maybe like 5 minutes after the last request. So what we would like to do is maybe call this stop self result sometime in the future, right? So that after some period of time passes, go ahead and make that conditional stop request that, hey, if I'm the last one to process, go ahead and shut down. If I'm not, keep me running. So we'd like to schedule this to run sometime in the future. And it turns out a good way for us to do that is using executors again. There's another type of executor, which is a scheduled executor, right? In fact, we take a look here. We go up here to our on our on create, and if I go to executors, and I can go here and I can actually get a new single threaded, and notice there's a scheduled executor. And that returns back a scheduled executor service. And what that actually allows me to do is say, run this request at some time in the future. So what I'm going to do here is that in my class, I'm going to create another reference to a scheduled executor service. And what I want to do now is I'm going to actually assign that here in onCreate. And so with that, I can actually, with the schedule stop service, I can schedule something to run in the future. And again, I have to implement runnable to do that. So what I really want to do is do my initial work here in run, and then I want to schedule this to run at some time in the future. So what I'm going to do now is implement another class that I'm actually going to use to make that delayed stop request. And what I want to do is I want to actually call that code inside of there. So what we're going to do is going to create a constructor just like I did on service runnable that accepts those references. So I'm just going to copy this code here. Paste that in, and of course I'm going to change my constructor name to be the correct name. And so what I want to do now is take this line, I'm going to put it down inside this run method. So now what I want to do is that after I get done doing my work, I'm going to create an instance of that delayed stop request. And I'm going to pass in the same parameters I've got, right? The service and start ID. And what I want to do now is I'm going to use that scheduled service I have here. Remember, look up here. I'm going to use this scheduled service. So what I can say is the service dot scheduled stop service. And what I want to do now is I want to go ahead and schedule that to run. So I'm going to use the schedule implementation. It takes in a runnable, which is my delayed stop request. And it takes in a value. So let's say I want to run this in 5 minutes. It takes in the integer value and then a time unit. And so what this would say as this code is written, whoops, I made a mistake here. I actually put the class name. I should have put the reference in. Let me just paste that in there. That makes a lot more sense, doesn't it? The actual implementation, excuse me, a reference to the actual implementation. Right, so what this says then is that I go ahead and create the instance of the delayed stop request, which has a runnable on it. And what that says is that, well, in 5 minutes from now, I want to run that runnable implementation. So what's going to happen then is that as I do my processing, and 5 minutes from now, it's going to do a stop self request with the start ID for that particular request. So basically what that says is that if no further operations have been requested of this service in the next 5 minutes, go ahead and shut down. But if other ones have happened, when the runnable implementation runs, we make the stop self request, the framework will say, no, there was other work to do, I'm not going to shut you down. So this implementation keeps our service running for 5 minutes after the last request. So it kind of keeps our service warmed up and ready to go as long as it's being actively used. If it's not being used, it will go ahead and shut itself down after 5 minutes. Right now, for demonstration purposes, I'm going to change this from 5 minutes to 10 seconds, just so we can see how it works in our demo. All right, so I'm just going to change that to a 10. I'm going to change my minutes to seconds here, so we can actually see how this all works for us. All right, so let's get a couple things here. Let's put a breakpoint in a couple places. We're going to put a breakpoint inside of our run here for where we actually do the work. I'm going to put a breakpoint inside of our run here for where we actually make the stop self request. I'm also going to put a breakpoint in our on destroy, because that'll tell us which stop request actually causes us to stop running, right? To actually shut down our service. All right, so let's go ahead and run this. So I'll say menu, do work. Of course, we hit our breakpoint where we actually do the work, as we would expect. So I'm going to switch back here. I'm going to do a menu, do work again. So I've made a second request to it. Of course, I hit my run handler again to do the work. Now, after some break, I'm actually going to go ahead and run the delayed stop request. So you see that the 10 seconds have elapsed since that first request finished. So I get my run to say stop self. I'm going to go ahead and let that run. And you notice that I didn't actually hit my on destroy, right? Because another request had come in. But now, when the timer for the second request fires off and the stop self for that runs, then in that case, when I actually call stop self result, the next thing my breakpoint should hit is the on destroy. So we've hit that point. I'm going to go ahead and let it run. And you notice now I hit the on destroy. So that worked exactly like we wanted it to, is that we continued running for some period of time after our last request, but then when requests stopped coming in, then we shut down. And of course, the beauty is that we didn't have to do a whole bunch of timing management around that, right? All we had to do was schedule the tasks to happen, right? To do the actual work and when we would like to make the stop request. Whether it was actually the appropriate time to stop or not was actually managed by the framework itself.